So in this video, we get to the new idea, which is this. It kind of should make sense. If my input is a number, then my output is a number, right? If my input x value is a value, a finite value, then my answer should be a finite value. But if my input is a variable, then my output should contain variables, right? It kind of makes sense that whatever you put in, that's what you get out. You put in a number, you get out a number. But I put in a variable, I get out a variable. And the way we do this, it's pretty straightforward. And this was the new idea for this week, which is when we do function composition, we're really putting one function inside of the other. And so remember that this is the composition symbol that says f composed with g of x or at x. But that really means f of g of x. And if you think about it, this is my inside function, which is this one. We are going to put that function, x squared plus 2x, inside of the outer function f. So what I advise students to do is look at the outside function. That would be the one in the green box. What we're going to do is we're going to create like a blueprint or a shell to put g of x inside of that. And if you've been reading it the way I've been reading it, it should just fall in place. So outside function is f. My function says 3 times my input minus 1. So I'm going to say 3 times my input minus 1. Because that's what the function says to do. But what we're about to do is substitute the whole g function rule inside of the parentheses. So the g function rule says take your input squared plus 2x. So my input squared plus 2x, this is now the composed function. I put one function inside of the other, and now I created my composition function. Now at this point, could we simplify? Maybe, sure. But I need you to know that this is the composition that we're looking for. Now, if you want to simplify, I guess you could distribute the 3 times this, use a little bit of algebra, plus 3 times 2x. If you triple 2x, that's 6x. And then don't forget the minus 1. So this is the correct answer. This is a cleaner version of the correct answer. But both of them are the composed functions together. Notice my input was a variable. My output has variables. It's a formula. It's an expression. It's not a value. 17, 18, and 19 is where no calculator can help you out unless it has an algebraic system. It really can't help you out because it's going to be spitting out a formula rather than a number. So we're going to try that again with number 18. G composed with f of x. That's what this symbol means, right? So what we're going to do is we're going to take the outside function and we're going to create like a blueprint of what we need or a shell of what we need. The g function says take your input, square it, plus 2 times your input. X squared plus 2x. Your input squared plus 2 times your input. So I'm going to do that. My input squared plus 2 times my input. But what am I going to put inside of that? Well, my inside function. It's going to go wherever there was a variable in my formula, I'm going to put the f function inside. What was the f function? 3x minus 1, 3x minus 1. This is the composition. Now, if I'm going to simplify it, that's going to take more algebra to do that, which I'm not going to do here. But this is the two functions, one inside of the other. That's it. Composition is about an inner function and an outer function. We're going to put the inside function wherever we see a variable on the outside function. Let's do it one more time. F composed with f at x. So I'm going to set up what I need for the outside function. The outside function says 3 times your input minus 1. How do I know that? Because that was the formula. 3 times x minus 1, 3 times my input minus 1. But what am I going to put in there? I'm going to put f of x in there, and f of x is 3x minus 1. I now have a function inside of the other function, which is what composition is. Now, can I simplify it? Sure. You can distribute the 3, you can put like terms together, and if you want to do that, feel free to do that, but 3 times 3x is 9x, 3 times minus 1 is minus 3, and then if you subtract the 1 that was already there, you're going to get this. But this algebra is kind of secondary to the bigger idea, and the bigger idea is how do you create a composition by putting one function inside of the other. Let's look at 24, 25, and 26. If I look at 24, remember, this is a symbol that means the same thing as this. And now I'm going to set up my outside function. My outside function is f. How do I know that's the outside function? Because the f is outside of the parentheses, whereas this is inside of the parentheses. So I'm going to set my outside function f. The formula says 2 times your x plus 3. 2 times your input plus 3. 2 times your input plus 3. But what am I going to put inside of there? I'm going to put the f of x formula, and the f of x formula is 2x plus 3. So I'm going to do this. That's my answer. I've composed f with itself, and I got this expression. Notice my input was an x. My output is an expression in terms of x. Again, if you want to simplify it, in this case, you can probably distribute quickly. 2 times 2x is 4x, plus 2 times 3 is 6, and then don't forget about this 3 at the end. So really it's 4x plus 9. That would be the simplified version of my answer that's here in green. But the bigger idea is, can you compose by taking one function the other, putting one inside the other? That's the key. We're going to do one more, and then I'm going to ask you to finish number 25, 21, and 22 that we didn't do together. And then you'll turn this in for a grade. So 26. 26 says, find g of f of x. Great. So I noticed that my outside function is g, so I go to my formula that says take your input, subtract 3, and then divide everything by 2. Okay. I'm going to take my input, subtract 3, and divide everything by 2. Input minus 3 divided by 2. Input minus 3 divided by 2. But what's my input? Well, my input is the f rule, so I'm going to dump the f rule in there, and the f rule is 2x plus 3, so I'm going to write 2x plus 3. I now created a composition of functions. Great. This is the answer. Is it simplified? No, but that is the answer. Now, if I were to simplify it, this is the same thing as 2x plus 3 minus 3 over 2. What's going to happen when I add 3 and subtract 3 at the same time? Those are going to cancel out. So then I'm left with 2x divided by 2. And what happens when I divide 2x by 2? Well, I'm left with 1x. So therefore, that's my simplified version. Again, we'll get more practice with the simplification. I'm concerned with, can you put the right function inside the outer function? That's what I'm concerned about. And so you're going to do number 25, 21, and 22, and turn that in as a participation grade for watching the videos.